is about developer support and associated things. First speaker is Catherine Newman from the DTC Development Testbed Center on testing and support. Catherine, go ahead and take it away. Sorry.
All right, thank you. Good morning, everyone. I'm Catherine Newman from NSF NCAR and the Developmental Testbed Center, and today I'm going to be discussing some of the testing and evaluation that we're doing that is in particular in support of our developers. So next slide, please. Okay, all right. So the DTC is a collaborative facility that has staff at both NCAR and at GSL, and so I wanted to acknowledge that I co-lead this task with Sam Trahan at GSL, and we have a number of folks that commit some of their time to these HAFS testing and evaluation activities, and given that there's some new names, I wanted to put some faces to those names. So I want to acknowledge the team. Next slide, please. All right, so over the last, I think 2, maybe 3 years, probably 2 years, I've had a similar talk in this type of session about developer support. And we've been discussing this eventual transition of the DTC away from the code management and developer support realm. And so I'm here today to let you know that we have, that transition has occurred. We in the DTC have stepped back from the code management and the developer and user support activities in support of the code last June. And this has enabled us to have additional emphasis on testing and evaluation activities. And so some of the different areas that we're working in, first is physics advancement and alternate physics, so looking at different parameterizations or configurations that could be run within the HAFS, model performance evaluation. I'm not going to talk about these two as much as the next two I'm going to be discussing here. So the first, teaming support for developers. So specifically looking at our DTC visitor program PIs and other PIs that are external to like the NOAA sphere. So through this, the goals are to identify promising innovations from the broader research community and work closely with those developers to have testing and evaluation that's iterative and working towards getting contributions into the code. And also gaining visibility from community contributions. And then we also have another task that's new in the past year, which is we're calling the MET+ based agile testing framework. So the goals here are to facilitate rapid performance feedback for innovations and accelerate research to operations specifically for community contributions. And so I'm going to be discussing these two areas in a bit more detail. So next slide, please. All right, so for the DTC visitor program, if you're not familiar, we provide support for visitors to come work with the DTC to test new forecasting or verification techniques for different models or model components. We have 2 different types of projects that could be awarded. One is a PI project where there's 2 months of salary support, travel, and per diem for a PI, and that can be broken up into several visits over the course of a year. We also have a graduate student option where a graduate student could come visit and get up to a year of temporary living expenses and travel, and also support for their advisor to come out and visit. So if you're interested in those, if you want to check out the announcement of opportunity on the DTC website, I have the URL at the bottom, or you can use the QR code there and it'll take you to that site. And so if you want to check out the areas of interest and the application guidelines. As far as hurricane-focused projects, we have a couple that are currently active. Both of these are actually kind of in the wrap-up stages, finishing up. The first is with Micah Iacono and John Henderson of AER, and their project is evaluating subgrid cloud variability enhancements and HAFS tropical cyclone predictions. And another from Xiaowu Bao at Coastal Carolina University, and his project is the evaluation of impact of different microphysics schemes on HAFS model QPF forecasts. So I'm going to give a little bit of highlight on each of these. So if you could, the next slide. All right, so for the project with Mike and John, so they are working on an investigation of cloud overlap methods within the RTMG radiation parameterization within HAFS. And looking at that schematic on the left side of the screen is showing some of the different cloud overlap methods that are in RTMG, and so they were testing The maximum random is the one that is currently in HAFS, and then they were testing the exponential, which is the one that's in the GFS V16, I believe, and then the exponential random overlap method, which is the one that they've transitioned into HWRF several years back. And the recommendation from their testing was to prioritize the exponential random cloud overlap method for future HAFS versions. And this recommendation came from some initial testing and evaluation that they did in collaboration with the DTC, covering several select storms. Based off of this, this finding, EMC took this and ran a seasonal retrospective for the 2023 season over the North Atlantic Basin, and they showed results that showed improvement over the baseline, which was a HAFS V2 baseline that they were looking at. And those plots are on the right-hand side, and these came from EMC. With track on the left and intensity on the right, this is skill relative to that HAFS V2A baseline for that entire 2023 North Atlantic Basin retrospective run. And we can see that outside of about 3 days in track and about 18 hours with the intensity, overall the signature is improvement over the baseline. So with that, Ben's talk yesterday, I believe it was, he had this listed as a potential to be included in the next HAFS implementation. So a successful outcome from this project. Next slide. All right, and then giving some highlights from Xiaowu's work. So Xiaowu is working on an evaluation of microphysics using GOES-R observations. Goals here to evaluate model skill in representing hydrometeors and complementing some work that the GTC was doing at the time with QPF evaluation. The finding here was that there was an overestimation of cloud coverage and height leading to larger cold temperature regions. This was based off of 3 storms in 2023 that he looked at. And I should mention that he was looking at HAFS V1 forecasts given the timing of this project or when it started. And so if you remember, the HAFS V1A version had the GFDL microphysics and the B version had the Thompson microphysics. So there was that difference in microphysics that he was looking at. And so what he did find is that while both had the same general trends, the Thompson microphysics had a more pronounced trend in this direction. And so looking at the figures, the upper right has composites from Hurricane Lee for the average brightness temperature. The 2 plots on the left are the model forecasts, and then the one on the right is the OBS. And so you can see that colder temperatures, and then below are PDFs for Hurricane Idalia on the left and Hurricane Lee on the right. The green line is the OBS, and then the orange and the blue are the model forecasts, and you can see those spikes in the colder regions. So Xiaowu is working on some further investigation of the sensitivity of the physics, looking at some hierarchical approaches, so using like SCM. And he is planning on having a seminar on this. It's not scheduled yet, but it will be broadly advertised. So next slide. Okay, so turning our attention to this agile testing framework that I mentioned in the beginning. So the goal here is to facilitate the rapid and straightforward comparison of experimental configurations and operational benchmarks. We're aiming this towards HAFS developers, community researchers, the DTC as we're doing testing evaluation and working with developers to do T&E. And then, as we can get results more quickly, it could help with decision making. One goal that we have where appropriate is to unify the approaches for incorporating MET+ into the UFS application workflows and to enable the use of MET+ for HAFS community developers to provide rapid performance feedback on innovations. And for anyone, if you are unaware what MET+ is, I thought I would just mention that it is the enhanced model evaluation tools, and it's a verification framework that is developed and supported in the DTC. Next slide, please. So where are we at with this? So we have a Rakota-based workflow that's running MET+ verification with HAFS, that's HAFS VX, and we're using the MET and MET+ installations built in SPACstack, which is supported by Epic on a number of different platforms. It currently runs parallel to the HAFS workflow or with stage model output, so it can be run with dependencies coming from the HAFS workflow, or you can stage a season of data or more and then be able to do the verification on that pre-staged data. It also is employing the unified workflow tools to be able to generate experiments from a YAML config file, so trying to look at some of the software practices across the different applications. We also are working on getting some documentation of benchmark runs and verification configurations, so things like the code hashes and physics and input and output locations, things that will make sure that everyone is working with the same benchmark or baselines. Also HAFS or Met Plus configurations for consistent verification, so making sure that everyone is using the same configurations. And the goal is to then have the verification run with the same general settings as what you would have at EMC or at NHC as you're doing verification, so that we're all using the same general verification. And then I have in italics this area that I think would be a nice add would be to have some known issues or key cases, so that as researchers want to run some innovation, some innovation they're working on, they have some idea of some areas that they should be looking at. Next slide, please. So the current capability is computing what I'm calling track-based metrics. Basically, it's using the HCCF files and verifying against the best track. So if you're familiar with Met Plus, that's TC pairs and TC stat tools. There's stratification options in Met Plus that are consistent with the NHC verification system. Track intensity and wind error, skill and relative performance are computed, and we have contingency table statistics that come up for rapid intensification. We're also working on plotting capabilities within Matplotlib, which is the Python-based plotting within Met Plus. And so I have some examples below of the types of plots that we are using or that we're porting over to Python and having available within Met Plus for plotting up the different kind of track-based verification. Next slide, please. So we're also have some upcoming functionality that we're starting to move out on. So of course we want to start verifying using the gridded forecasts, the gridded model output to compute metrics. So some of the tools that we've identified are GridStat, PointStat, series analysis, and TCRMW, if you're familiar with Met Plus. I have some kind of postage stamp plots below showing some examples of some of the output that we have from those different tools. There's a few others that we also have on the list. But basically, we're working with some of the Met Plus use cases that we have and some of the verification workflows that we have internally to show up some of these different capabilities to be able to get them ready to put into the workflow. And so one consideration for this type of verification, of course, is the observation. The data ingest for the observations is a little bit more complex than just bringing in the ATCF best track files. We're also working towards command line plotting using the Matplotlib plots. So this enables the ability to generate the plots on the same machine that you're doing the verifications. So you don't have to worry about loading a database or moving the files. And then also with gridded verification, we have the ability to do things like scorecards that I'm showing an example from the RFS. Where we have, the output from the scorecards, and then we have this interactive option that we've been building out where you could click on a particular row or column and have the plot that corresponds to that to be able to look and see. So I do want to bring up that while this is starting to get to be a pretty large laundry list, we actually do have the advantage of having the integration of some of the additional functionality being a little bit easier to lift, because it's aided by some significant overlap with the functionality currently in the short range weather app. And so the DTC has been working on an RFS-based agile framework for a number of years. And so we are, a team that's working together and making sure that we can integrate where appropriate some of the functionality that's already been developed through that funding. Next slide, please. All right, so don't know how I'm doing on time here. So for a summary, the DTC Visitor Program remains a strong avenue for broader engagement with community developers. So feel free to visit the website or contact team members or myself if you have questions. For the Agile framework, this is an ongoing, activity that's been started up in the last year. And so next steps here in the immediate future are to conclude some of our internal testing and then get it moved over to a feature branch within the HAFS community repository. We're currently working in a fork. And then have some demonstration and collect feedback and priorities from the UFS Hurricane team, application team. Obviously, we have our laundry list that I just showed, but there's other, we want to make sure that we are prioritizing the things that are of most interest to the team and usability from folks that would be using this functionality. And then, enhancing those capabilities and improving the documentation, of course. So with that, I guess, hopefully I'm not too off time. Okay, all right, thank you.
Thank you, Katrin. We'll go to the Q&A session at the end and have a lot of discussions of Katrin is doing. And welcome Cameron Wu, Epic Development Support. Cameron, go on.
Good morning, everyone. Thanks so much for having me here. Should I share my slides from my end?
We got it. Yeah, obviously, we're in the process of loading them right now.
Oh, okay. All right. Thanks.
Unless it's easier for you to do it there, but we've got them up.
Okay. Nope. Nope. Over there is perfectly fine. Thank you very much.
Great, thank you.
Okay. Yeah. Good morning, everyone, and thanks so much for having me here at the HFIP meeting this year. I am the product owner of the software integration team at NOAA Epic, and I'm here today to talk about a bit about Epic HAFS support and what our current involvement is with HAFS and the UFS Hurricane app. This presentation was developed by me and also jointly by Jillian Petro, who is leads the user support team at NOAA Epic. Next slide, please. Okay, so the current contributions Epic is making to HAFS include facilitating the biweekly HAFS developers meeting. So I facilitate that meeting every other week, and then Jillian and the US team primarily coordinate limited user support for the HAFS repository and contribute to HAFS documentation. And I'll expound upon each of these points in the coming slides. Next slide, please. So for the biweekly HAFS developers meeting, this was an ongoing call that Epic began to lead after the transition from DTC. So we picked it up some time ago. And so primarily it's a meeting that with the HAFS community, as well as other members of the broader hurricane community. So we have NOAA EMC, we have OSTI, AOML, we have Epic, DTC, UCAR, and folks joining from several other institutions within NOAA and outside NOAA on a case-by-case basis, depending on the meeting and the content. And sometimes we have special topics during the call. So during the meeting, we review active pull requests and issues in the HAFS repository. So we go over them with some of the lead HAFS developers and talk about what's going on with the PR, what's going on with the issues, and facilitate discussion, working toward resolutions for those issues, and just getting updates regarding the GitHub PRs and issues. And then we also discuss ongoing development related to HAFS. This includes ongoing real-time experiments and just updates from the various teams looking at different HAFS configurations. So it's pretty active in the fall time during the storm season, which is always really interesting and exciting discussions there. We also had to discuss data assimilation and advancements. Recently, some discussions about incorporating JEDI into HAFS. Talk about moving nests and basin scale configurations, HAFS and MOM6 coupling, and then we have occasional walk-on topics regarding software issues, backstack issues in HAFS or other HAFS components, model issues such as trying to run HAFS with GFS version 17, initial conditions, and then just some technical issues. So we try to just coordinate discussion and bring folks together to try to converge on solutions for those issues. Next slide, please. So the second facet of Epic's involvement with HAFS right now is limited user support coordination. So I mentioned Jillian Petro. So she and her team, the US team at Epic, oversee this. So they primarily are monitoring the GitHub discussions tab of the Epic Health dashboard, and there's a link in the slides for anyone interested in visiting that website. So they're checking regularly for incoming discussions, and so they handle questions on dependencies. So some of those they're often spec stack related. The spec stack's regularly evolving and needs to be incorporated and updated in HAFS, and the weather model and other components pretty often, and issues can arise there. And they also reach out to HAFS developers for assistance on other topics. So, primarily scientific topics and HAFS workflow or software related topics that are beyond the scope of Epic subject matter expertise. Next slide, please. Okay, so the US team at Epic is also involved with HAFS documentation updates. So they're regularly submitting PRs to update the documentation insofar as they have capacity to do so. So there's a list here of some recent pull requests that they've submitted, and I believe actually all of these have been merged. So you can see here just some of the things that are going on. High-level reorganization of the documentation on the Read the Docs website for HAFS. Link checkers and contribution guidelines were updated, and then adding the HAFS V2 release notes and associated physics information are just some of the examples. Currently, EPIC isn't planning its own documentation updates to the HAFS repository, but HAFS users and developers may reach out to EPIC to request updates to the documentation. And we also discuss this actively in the bi-weekly developers call. Next slide, please. So I wanted to touch briefly on the UFS weather model and its associated components and applications. So as many of you know, in HAFS, in the source, the UFS weather model is used there as the primary forecast model. So in terms of the UFS weather model, the infrastructure has been developed to build the unified system to support various configurations. And you can see a list here of several different types of configurations, and these are constantly being updated, and new configurations are being added. I think recently, UFS fire capabilities were added, and that list continues to grow. And along, we have atmosphere only, atmosphere land, Rufus, subseasonal, seasonal, and then the fully coupled model, S2S with waves and aerosols. But I bring this up because the HAFS configurations are also available in the UFS weather model and are supported. And then these configurations are actively tested against updates to key core libraries that are maintained in SPACStack, such as FMS, ESMF, NetCDF, HDF5. And this UFS weather model development and pull requests are very frequent, and so these configurations are getting tested at high frequencies. Next slide, please. So here's just an example of some of those HAFS configurations. So these are baselines that are maintained and regression tests that are maintained by the UFS weather model code management, which is primarily overseen by EPIC. And so there's a list here. You can see after the run steps, you're compiling the same configuration, which is that HAFS SW or HAFS W, and then the actual baselines and specific HAFS configurations are listed after each run step here. So, you have HAFS regional ATM, HAFS with atmosphere and ocean, atmosphere and wave, coupled with atmosphere, ocean, and wave, and different HAFS configurations with various nesting and storm following nests, etc. So these regression tests are run, I believe, with every pull request that is going to be merged into the weather model, just to ensure that code changes that are being brought in elsewhere to the repo aren't affecting these HAFS configurations, but also allow these configurations to be tested against new functionality and updates to core components of the weather model and libraries as well. Next slide, please. So just a quick discussion here about UFS applications in general. So typically, a UFS application will combine a numerical modeling system, such as the UFS weather model, and then components such as DA components, post-processing features, and then a high-level workflow. So the applications can be configured for research or operational needs, and the different configurations can use subsets of the entire system. So many components are available. Based on the configuration, they can be optimized or selected based on the user's needs. So some of the primary UFS weather applications currently include the global applications, such as GFS, and then the others listed there. Short-range weather application, and then that is the code base for the rapid refresh forecast system and the warn-on forecast system. And additionally, the hurricane application, which serves as the code base for the hurricane analysis and forecast system. And an EPIC service desk has been established to provide user support and ensure access and usability by all community members. So after the presentation, if you're interested, feel free to just go to that link, and you'll see various ways to get service and submit requests to EPIC relating to these applications. Next slide, please. Okay, just wanted to go over also just EPIC's UFS weather model support. So like I said, EPIC is leading the code management for the UFS weather model at this time. And so that consists primarily of PR and issue maintenance, testing pull requests, reviewing pull requests, and then, the final merging. So it's a suite of activities, ongoing involvement with, various communities that are contributing and working with the UFS weather model. EPIC also provides user support for discussions and issues in the UFS weather model repository itself. So users can go to those pages, discussions or issues, and submit an issue, open a discussion, and receive support directly from EPIC, or be routed to a subject matter expert. And for issues, it depends on the nature of the issue. If EPIC will handle it, if that is handled by another institution involved with the code management, or a developer specifically working on a related issue. So there are links here for the NOAA EPIC Get Support page and Get Code pages. So other ways to just go on and get help, or just download code if you're interested in taking a look. Next slide, please. So EPIC also provides stack support on all the NOAA Tier 1 platforms. So just a quick overview, SPAC is a joint effort between EPIC, EMC, JCSDA, the Naval Research Lab, NRL, and some other agencies. And that list is often expanding. So EPIC maintains SPAC on all of the Tier 1 RDHPCS platforms to support the UFS weather model and other UFS applications like SRW, the LandEA offline workflow. So those are under direct support through EPIC, but there are several other repositories and UFS related applications or workflows that use it, such as Global Workflow, UPP, HAFS uses, I believe, currently SPAC 1.6.0, and then the subcomponents of the HAFS repository utilize SPAC as well. And just for those who may not know, SPAC replaced this HPC stack, I believe, in August of 2020 through to, I can't remember the exact year. So it came in at version 1.4.1, I believe, and now it's actually about to release SPAC 1.9. But HAFS is currently at version 1.6, which is the same version that the UFS Weather Model Developer Branch is currently using. So in terms of EPIC's involvement with SPAC, like I said, EPIC maintains it on all the Tier 1 platforms. So that includes installations, updates to those stacks, bug fixes, etc. We offer user support via SPAC and UFS repo discussions and issues pages. So you can go to the SPAC repo and open an issue, requesting a new library or need help with SPAC issue in your application, or whatever code you're working on that utilizes SPAC. And if you have additional questions regarding SPAC on NOAA maintained platforms, please email that support.epic@noaa.gov email, and we'd be glad to help out. Next slide, please. I also wanted to touch briefly on the UFS testing framework. It's the developmental testing framework that was integrated into the UFS weather model as the so-called test dev directory a few months ago, and some idealized test cases that are being added and actually recently were merged into the weather model. So it's a developmental testing framework that was added that kind of parallels the traditional regression test and test directory that offers different configurations and testing options in the weather model. And it's a developmental test bed there. So it's to test to just look into different ways of configuring, run different testing options, and looking at changing performance efficiency in regression testing systems, adding options for adding different types of cases outside of the standard regression testing suite. For example, we recently added 2 idealized test cases to the UFS weather model, which will be officially announced in next week. There's a baroclinic wave test and then a UFS case study from the old UFS case studies website. And I mention this just because there is an option to potentially add HAFS or hurricane cases to this testing framework. I know that there were some idealized cases utilized in a previous workshop, I believe last summer in a colloquium, and so test cases like that could be synced in. Next slide, please. Just wanted to mention that EPIC maintains a suite of containers for various UFS applications for the SRW, Land EA, and currently working on a global workflow container. So these are on Docker Hub and just containerized versions of these applications that can be downloaded by the user, and so they can run them on different machines. So that is something that EPIC does offer. Next slide, please. So I just wanted in summary here, list some links in an email for users who would like to reach out to receive EPIC support. And you can go to these enhancements category on the discussions page to request enhancements on the HAFS repository or the UFS community repository. Like I said, please reach out with requests to that email. And then we look into each one of those requests and allocate it as we have capability. So that's the end of the presentation. Thank you so much for listening, and thank you for your time and inviting me.
Thank you, Cameron. Appreciate it. Our next speaker, since Cameron mentioned the colloquium last year, is Dr. Sen Chow, Director of NCAS-M at Howard University. And he was speaking about the successes of what we were able to accomplish with the colloquium done with NCAS and the HAFS team. Give us a second to load your slides, Sen.
Thank you. Thank you very much. All right.
Okay, so.
Thanks. Thanks for this opportunity to be here presenting some results. I wish I can be there, but much warmer for that way. We have some cold weather these few days. All right, so the title is talk about the success of the HFIP and NCAS-M HAFS summer colloquium. This is a very, very interesting topic, and I want to say that next slide, please. I want to say that this is actually sort of like a sitting here, listen to in the past few days, the presentations that really make me think how to emphasize or how to address this is kind of a emerging issue related to how we train the next generation future workforce for NOAA, for example. So this is actually the area I'm going to touch for today's presentation. Talk about NCAS-M. I think most of you may not necessarily know what NCAS-M is. I will give you a little bit 1-2 minutes update about that, and then talk about how we start the idea of this the colloquium training and the lesson learned, and give you some example of the output from one or two of our attendees in that. And then next step. Next slide, please. So for those of you actually not necessarily knowing NCAS-M, which is one of the NOAA, which is one of the 4 NOAA Cooperative Science Center. We are here at Howard, which is the NOAA Cooperative Science Center in Atmospheric Science and Meteorology. So as you can see this slide here, basically our target is to produce a diverse and highly skilled and technically environmental literature professional for the future NOAA workforce that to deal with all those extreme events or other environmental threats. So that's actually very straightforward in terms of how we plan ourselves, in terms of training, in terms of education, in terms of research, aligning on this primary goal. Again, the second part of that, you can see that the objective for this, for NCSM, which is the research training and graduation, STEM diversity, and our workforce impact. I kind of like shortening a little bit because it's actually quite long than that. I want to mention that in terms of our NCSM, which is, we have another 7 part. Yes, the next slide, please. That's fine. So I want to say that we have 7 different partners around the country, from SUNY Albany to UMBC to UMD to Puerto Rico, Texas, Jackson, San Jose, and Howard University. So those are our partners. The unique opportunity, I'm going to touch a little bit on this unique opportunity in terms of coming up with this training idea. It all happened last year in January in Baltimore, the AMS annual meeting. So somehow Gopo and myself and Aaron, we were on one of the corner, come up with the thing, talk about the training. It's interesting. It's just like from some kind of chit chat, it went out like a develop into something I don't even expect. But anyway, so we talk about the training part of it because, again, as the previous slide say, we are very much aligned the thing that we want to train our future students in terms of workforce. So we end up talking about that. And then again, HAFS model is, I put it on slide here, which is a very, very unique, the model that currently most of you actually using that, and we do see the needs in terms of how we actually train our students, especially underrepresented group of students, that to be able to be part of it, and then know how to use it, and then even involved in future research project. So with that, starting from January timeframe, we have a very ambitious goal that have the colloquium in May, which is only a few months, as you can imagine that. So next slide, please. No, I kind of skip a lot from January to May in terms of that happen. So we do have quite a few meetings to really plan ahead of the things, as well as the details. I cannot thank enough to know our colleagues to really make this happen. We'll talk about that. Again, the goal, the training framework here is basically covering, we kind of like try to think about how we want to have the hands-on in short period of time, only a few days for this workshop, with the hands-on, with the concept, with all the ideas, and then how we actually crank everything into that few days. Then with students may or may not have the experience or idea of what is HAFS or how things like that. Instead of they ask a ChatGPT, but then we bring HAFS to them. So as you can see, lectures talk about the infrastructure, talk about the model, talk about the nested initialization, everything we cover, pretty much everything. Configuration, those hands-on exercise, those are actually, I want to say that's actually designed in a sense really can implement to any other workshop or training workshop. That's just perfect. Again, talk about, definitely we have NCEP high level fellow colleague to talk about the future in terms of how we do things, and we're practice session about that. Next slide, please. Go back. Yes. Thank you. So lesson learned here. Basically, as I say, we prepared quite a bit, and it's such a tremendous amount of time from each individual making things happen that way. Student engagement, preparation. That's actually also another big push in terms of getting students involved, getting the NOAA, especially EMC, HRD folks that really prepare the things to talk about that on site. Thanks to NCWCP, the conference room, that's perfect site location for that. We have other things set up like a Slack as well. So that's just another big part of it. Follow up, which is very, very important, especially this kind of curriculum training. It's always the case that follow up things to make sure we have some kind of outcome. So next slide, please. So this is actually one of the example. I just want to kind of like most of you actually know in terms of Hurricane Beryl in this case, but I just want to show you one example that in terms of result from this trend. Now, retrospectively thinking is, I want to touch a little bit on that, how in a typical setting, like this many students or postdoc attending this training, and then you will wonder how many of them actually really came out know how to do it. Now, this is just one of the example. Next slide, please. Yes. So again, using that, we just simply grab the case looking into Hurricane Beryl in terms of the 2 times of the rapid intensification. So as you can see, this is the result. We test the HAFS A. We've even included the actual. We test different the new configuration, HAFS TK configuration as well. As you can see, the result. Not necessarily sort of like in progress right now, kind of like trying to figure out how things are, in terms of how to not only running the model, but further next step into invest, do the research for the intensity or the track or things like that. Next slide, please. So yeah, for example, this is one of the simulation results from our focus hour 9 and 18, looking into comparing to the satellites. I'm not going to talk about too much on that one, but just give you the flavor in terms of how individual of the trainee can be able to reach to that point that then run the model and then make some plots. This is considering some sort of like a progress that we all want to see it. Next slide. So I want to spend a little bit of time on this slide to kind of summarize 3 days. If I counted correct, we have 15 lectures. Like I can do double count. Anyway, 25 plus attendees. Actually, more than 25, 20 something. I forgot the number. In person already 20 something, 20 plus online. There's a remote, which is really another lesson learned from this kind of training. Especially the hands-on session. The remote part is really not necessarily working that well. I want to say that 20 plus NOAA colleagues contribute to the lectures and the hands-on sections. 20 plus. I wish I could list all the names, but it's actually on website. Now, sir, the number 4 point here is recruiting students. This is another big thing. We are not just want the quantity, but we also need the quality in terms of how we want to train our students to get the right student or to align with the interests of doing the model. That's actually, I'm still learning on that one, actually. I have to say that. One big part of it is actually trying to help students to understand NOAA, eventually get into NOAA. Increasing the dialogue between CAC, for NKSM and NOAA to generate more collaborative research, which is also a very big thing to us. Engagement with NOAA and looking into the future opportunity and then working, especially connecting students with NOAA colleagues. Now, certainly the last bullet point here is how we actually prepare our students and be able to communicate well with NOAA colleagues. Next slide, which is the last one, acknowledgement. I want to end here basically. I wish I can, well, you can click on the website. That's all the pictures in terms of our NOAA colleagues, the lecturers, speakers basically talk about for the workshop. Big, huge thanks to all of that. Again, thanks to NOAA EPP MSI office to make this thing, to support financially, to support our students. Again, big thanks to LML, HRB, and NSET, EMC, and to make this happen. So with that, I want to end here, and I think you can actually get this slide, access the slide and click on the link to the USC website. Everything's there, including lecture notes as well. Thank you.
Thank you, Sen. I just want to add on to what Sen was talking about, that it was a real privilege for all of us from the NOAA side to work with your students. We got a lot more out of it than I think we were expecting or hoping for. And we're looking to do more in the future as we move along. Also, there was a question in the chat that Will had answered. We do have the materials that were used, both the lecture and the code linked on hfip.no.gov. And then, of course, there's also the GitHub for the HAFS code that's publicly available. Gopal.
Yeah, we should thank Sen, and of course, this was the first motive. I was personally very, very motivated. It started with a sidebar conversation in one of the AMS meetings last January, and thanks to EMC and AOML, all the participants there for developing this in such a quick time, a tutorial, and which ran for 3-4 days, and there is a success coming out of it. Personally, I feel delighted, as well as very, there is a sense of success in this, and creating the next generation capacity. And thanks to everyone that helped me to do this, along with Sem, Aaron, Vijay, Abichal, you name them, people out here, Task gave a lecture, and then Zach started it, and then Bin, yes, big thanks to Bin, Andy, you name who are the people, yeah, us here. Plus, if I had missed somebody, they had put in all efforts. Hinsuk gave ocean couple talk. Yes, I'm sorry. It's so, and there were several more, and it was a delightful experience. Personally, I felt that it was a high water mark for me for that year. And Bill, I shouldn't miss Bill. So anyway, moving on, we have the next talk from RDHPCS system updated and new system information. Very important about the new system information. Leslie, come on. Leslie Hart.
Hello, this is Forrest. Can you hear me fine?
Yes.
We can hear you,
All right. Leslie is sick today, not feeling well, so he's on the meeting but won't be able to talk. He's kind of lost his voice, so I'm going to go through his slides for him. He will comment in chat, and Eric is on also to help go through this if we need help. So can you go to the third slide? Here we go. So the new system, the next new system that we're getting is called URSA. We expect it to be available early next year. We hope that will be January, by the end of January, but it's still a little too early to tell. They've been having vendor supply problems. Our integrator, GDIT, has been having vendor supply problems on the compute side. Everything looks good on the file system side. Equipment's there. It's, best we know, without a compute system, it's running good, but there's been lots of issues, relatively minor issues, but delays on the compute side. So we're hoping for, still hoping for January. The system is AMD Genoa, 96 cores per chip, 2 chips, so 192 cores in a node. Got InfiniBand NDR200. File system is DDN Luster. You can see the numbers there. There's going to be 634 nodes available, and of those, 58 of them are going to have two H100 GPUs. There's also a exploratory system with some Grace Hoppers, Xeons, etc. Next slide. OS going to be Rocky 9. So that's going to be similar to Hercules and Orion, the machines at MSU, but different than Hera and Jet, which are still Rocky 8. Well, will remain Rocky 8. There is going to be an early access TDS system, test and development system. We hope in December. We hope at least a month ahead of the compute system. Again, the delivery times are a little bit up in the air right now. If there are people interested in accessing that TDS, hopefully a month ahead of the compute system, please submit a help ticket. The address is there, but if you just use any help address, use a Hera help if you don't remember this one, and tell us that you want early access to the URSA system. When that's available, we'll get back to you. We already talked about the delivery of that system. So next slide. This is the front ends, 4 nodes for the front ends. There's going to be a service partition, somewhat similar to the current layout. So I don't expect a lot of changes there. I mean, it'll be running its own Slurm instance.
Just a quick comment. Can I add a quick comment?
Sure.
Yeah, basically, yeah, Leslie added a note. The test system will be coming soon, maybe early January. But we have a pre-test system. That's what the previous slide was referring to. If somebody is interested in using that, that is available now, and they can do some testing, initial testing. To access that, you can just send an email like it mentioned on the previous slide. If you can go back to one slide, please. So the pre-TDS, that part is available now, but it doesn't. If that is something, if you'd like to do some early testing, we'd like you to let us know. Only thing is, it doesn't have SPAC stack available yet. So if you're dependent on SPAC stack, this one may not be very useful for you. But if there are some things that you would like to test without SPAC stack, or that's something that's not dependent on SPAC stack, we welcome you to contact us so that you can do some early testing. Yeah, sorry. Go ahead.
No problem. Thanks for stepping in. All right, so I think we can go to slide 6. OS is Rocky 9. Slurm will be the batch system. It'll have its own instance of Slurm. SPAC stack, already mentioned that. Raghu just did. It looks similar to the way we are on the MSU systems. So we'll have an Intel stack, an AMD, an NVIDIA, and newer versions of the compilers. So I think we've pretty much covered all that. So we can go to the next slide. So Rhea. Rhea is the next system. Will be a file system upgrade. So the thing that's going to happen first with task order 40, the Rhea system, is that we'll be upgrading the file systems, enlarging the file systems, adding a vast file system, and integrating the file systems all together so that Hera, URSA, and Rhea will be sharing the same file system. So again, that date is a little bit TBD. The Rhea file systems haven't shown up yet, but we hope that'll be in early 2025. The Hera file system goes out of support at the end of August, and we do want to have a couple months overlap so that people can get all their data off of the Hera file system, Scratch 1 and 2, and on the Scratch 3 and 4 and 5 in time, but we should have plenty of overlap. unless we experience some kind of vendor delay on this. But these are much more performant file systems. Scratch 5 is a VAS file system, a flash file system. So we should see some significant, speed ups with the file systems that will result here with Scratch 3, 4, and 5. All right, next slide. So the current fine grain or FGE system will be decommissioned after the URSA GPUs are in production and running well. We just mentioned the HERA file systems will be going out of support by the end of August of next year, but we should have plenty of time to be migrated over to the new Scratch file systems in the spring of 2025. So we should have a 2 or 3 month minimum buffer once everybody is off of Scratch 1 and 2. And then we also have some Niagara changes. So Niagara is going out of service in the first part of 2025. It will be replaced by a system we're going to call Mercury. It will not have any compute. It'll be only front ends and DTNs. But it'll be doing the same function that you've been using Niagara for moving data, migrating data, etc., between systems. All right, next slide. So coming in 2026, and it's very TBD when that's going to be. We hope it's early 2026, but it's too early to tell. Will be another AMD-based system called Rhea. And again, this is going to be a much bigger system. And you can see the chips that it's going to have, and it's going to bring us more GPUs and more standard compute. And we've already talked about the file system upgrades to Scratch 3, 4, and 5. It's going to have 1,380 nodes versus the 600 roughly nodes on the other machine, and 138 of those are going to be GPUs. So it's about twice the size of URSA. There's a lot of facility work that has to be done in West Virginia at the NESC to make this happen, and that's probably the biggest issue that we currently have, is knowing when those facilities are going to be ready. But yeah, so that's Rhea. Next slide. Here's a comparison between the current NOAA systems. I'm just going to let you guys look at that a little bit. And since this is the end of the presentation, basically, well, we have a schedule, one more schedule here. There's lots of data on here that compares the different systems: JET, HERA, MSU, WCOS, and C6. So there's similarities and differences between all of these systems, as you can see, if you follow the colors of these squares. So I think we'll wait and let you ask questions if you got questions on this. So next slide. And this is the schedule we've been talking about. I think we've covered all the options here already. So I think we should open it up for questions.
So Forrest, we were going to have Ray do his slides and then do discussion of everything.
Oh, that's great.
Is that all right with you? Because it's.
Oh yeah, that's fine. That's fine. We'll handle questions after that one.
Perfect.
Here, sounds good.
Thank you. So with that said, our next presentation also relates to RDHPC, and that will be coming from Hui Yu, I believe. Just give us a second to get the slides up. And since we are a little off schedule, I just wanted to update everyone so they know where we're at. So we have a hard stop at 12:30. That's the most amount of time I could wiggle out so that we can still have the lunch break. And Will, are you ready to go?
Yeah. Thank you, Aaron.
Okay, thank you.
My name is Wei Yu. So we are supporting the NOAA RDH PCS for both the regular users and the real-time experiments. Next, please. So this talk, we will give a summary for the real-time experiments for this year, and we also looking forward to the next year. So next, please. So this is a summary for this year's HFIP user experiments. So we have the 4 projects, so totally about 13 million core hours allocated on JET. So the reservation started on July 1st and still running. So expected is November 18, but we are watching for the active storms. And the major users this year is from the NSAP, AOML, and GSL. The reservations allocated on different JET partitions. The major computation resource is from the XJET, the post-process, and one model runs is on the VJET, and the post-process on SJET. And there is one user post-process required for big memory node, so we give this user on the KJET. We also have the reservation on front nodes to guarantee the successful download of NSAP data. So the benefits for the reservation spread on different JET allocations is to guarantee that the real-time experiments can run successfully. If some of the JET nodes have problem, next please. So this is a summary of the major issues we have in this year. Actually, the major issues is happened on the file system. So from February to May, we have the OS migration from the Rocket 7 to Rocket 8. This happened on both JET and Harrier. So before the real-time started, so we make sure all the application software supported by our group, so that one is ready. So and for the LFS 4 and LFS 5, so it has some issues. For the LFS 4, we know that code, we predict that one could be a problem. So before the real-time experiments started, so we tell all the real-time users to transfer to the LFS 5. But during the experiments, we still see some dependency from both real-time users from HFIP and GSL. So, and also the regular users, they still have some dependency on the LFS 4 system. So that gives us another lessons for the future, since the migration for the users application could take longer time than we expected. So for the LFS 5, so this one is now a major file system on the JET clusters. So there is issues is it only happened on the old JET. So that crash computer nodes from time to time. The main reason is the incompatible of the software with the old JET, and we worked with the vendor, so that is updated on the file system, and this one was completely solved after the updating on September 17th. So that's after that, basically the JET runs stable. So another one is the normal issues. That's for the computer normal issues, like the RB switch or network have some issues. So that one happens once in a while. So this year it also happened, and the system engineers fixed that one once it happened. We also have another issue related to the user workflow. That's the computation performance variation. So this one is the jobs occasionally kill due to the timeout. So basically, those kind of issues can be solved by adjust the reservations. And we also have the NSAP data sometimes arrive late, and in the user workflow, so not consider this situation enough. So and in the future, we may address all those issues in our document for the real-time users. And we can double check when review the proposal to avoid this kind of issues. And we also have another one is normal computer issues. The nodes occasionally slow or fail. So for the node fail, the current system can automatically find that problem and pull out the bad node. So this kind of node fail only affect one cycle runs. But node slow performance, just a little bit slow, is not completely down. So this is still a challenge. So far, we have some benchmark, so that can help to identify those slow nodes. Another one is the user tickets. In the future, we still want the user to provide more detailed information. So user don't need to worry about whether they give a wrong judgment. Since once we see the ticket, usually we can, based on user's information, we can double check what's the reason. So that can help for the quickly located to the issues. Next, please. And the summary of the reservation usage. So for the current HFIP users, we give a summary. So it looks like the forecast job. So that reservation usually have a good utilization. It's above 95%. So that's a very good performance. For the initial jobs, have a poor utilization. Mostly is less than 40% of the resource usage. So we just give several points that's likely to be a problem, like the reservation is waiting for the initial data. And also we have the auto release is 15 minutes. So this one can be, we can try to improve in the future to adjust the workflow. And the post-process jobs also have some of the post-process jobs do not have a good utilization. We can discuss later. So for this reason, and we also see some some unlisted reservations that the resource was held and not used. Next, please. So this gives the example of the typical reservation usage. So the left 4 panels is for the initialization. The right 4 panels is for the forecast jobs. So generally, you can see the forecast jobs. If run the each color bar that represents for 1 day's jobs running of the usage. So if it's white, please, that means the resource was released for any users, for regular user to use. If it's if the red is held all the time, that means the resource was held by the reservations and not used. So that's kind of the wasting of the resource. The green color, that means the resource was used. So for the right panel, you can see the usage is pretty high. It's very good. And there's some also auto release, like the red part. So that one means the forecast job. So it has the 4 hours time windows. If you release that resource earlier, the other regular jobs can cut in to use the resource. But since the forecast job has 4 hours windows, so basically if user's job gives the work clock time 3 hours window, you can, in this case, you can use this resource. So that gives a general idea, but for the left side, we can see the usage not very higher. So we are going to try to improve in the future. But this year we see since the users also have some issues with the file system, so it's very busy. So we didn't didn't talk to the user for how to fix this one. So next, please. This gives the jet usage. The left side is we assume the reservations are 100% used. So this plot includes both the GSL real-time reservation and the HFIP real-time reservation. So GSL reservation we didn't show here, so we just see the HFIP reservation usage. If we the pink the dash line, that's the red line, the dash red line, that's the allocations. But we can see if we think the reservation are 100% used, so we still see some of the users use outside the reservation. That improves the usage. So the right figure, that's the actual usage. So that one is, we can see for the HFIP usage is a little bit low. So that's normal, since if no storms, user can release the reservations. And also, if the user do not run the jobs there, and we have the Slurm settings to automatically release the reservations in 15 minutes. So that's and another part we can see that one for the jet black line. That one goes down. Since the main reason is from this figure we can see that the reservations did affect the actual usage. Since the general idea, just as I showed in the previous slide, the reservation cut the resource as a small piece. So some of the reservation can be used by the user, some may not. And also for the regular user, if you want to use the resource, so you need to adjust your regular batch job to fit in the time window. So if for example we do have the users use regular user tickets ask us for the slow turnaround time on the queue, so we tell the user to use a small workload time, so that can have quick time in for those release resource. So that gives a general idea. For the regular user, it's really hard to fit in. Next, please. So if you have any questions or comments for the 2024. Okay, so now we're looking forward to 25. So next year we expected the reservation HFIP to move to the ERSA system. So the first one, we want the user start your migration as soon as possible. So the major part, I think, is for the compiling. So that's the new compiling system. And I think from our side, we may have another software stack on the header. If user wants to start for the compiling part, use a new software stack that could happen as early as possible. And the new scaling testers, so that will be required for the next year. And for the reservation usage improvements, so first one, we want to make sure the reservations will not take time to wait for data arrival. So basically, we will have request the user to have to check the data availability before submitting the jobs. And also the initialization forecast reservations on post-process. So especially for the initializations and the forecast reservations, the idle time, we want to change that one from 15 minutes to 5 minutes. So that idle time basically means when the reservation becomes active, if you don't have any jobs waiting on the queue or using the reservations. So in that case, only 5 minutes, it will automatically release the reservations. So the regular user can use that resource. Next, please. So this gives the examples. So for the modeling scaling test, so we want the user to give this kind of testings for basically based on these figures. So we use the Wolf model. So this is a small domain. So basically we can see that one. If you use the 1,000 over 1,000 MPR task, the performance goes down. So basically we want this kind of scaling testers, so user knows where they can efficiently use the resource. So this will be requested for next year's proposal review. Next, please. So, and this is examples how we do the reservations, and this from the user's workflow. The yellow is for the initial reservations. So basically, the user's initial jobs will happen in these reservations. So the white block, that means could be we can have some improvements. That means the kind of resource wasting, so we can improve in the future. And the green part, that's for the forecast job reservations. So that's just one part. So that's straightforward. That have very good usage there. And the blue part is for the post process. So in the current real-time users, the forecast jobs and post jobs, those two reservations are overlapped. That means the post process will waiting the jobs, waiting the data output from the forecast. So in the future, we may tune this part a little bit. If we start the post process a little bit late, so that can reduce the waiting time. So that can improve the usage for the computation resource. Yeah, next please. I think that's could be the end. Yeah. So I think now we open for the questions and discussion.
Thank you. I think we'll start this discussions with whatever happened during this session. So if anyone would like to start off, basically, questions, either for HPC or support that Catherine was talking about. Or HAFS tutorial, whatever. Thought Vijay is going to come up. Yes.
Well, I don't have a question, but I wanted to make a comment and also compliment the team, particularly for the JET, led by Forrest, Vayu, and several other people who have been helping us with the real-time experiments run as smoothly as possible. And thanks for the extra support. The team definitely benefited from lively interactions. The chat room conversations helped address any issues immediately. So I really want to express my gratitude and kudos to the entire JET team for helping us many years, and this year even better. I'm looking forward to working with you all next year again on URSA, hopefully. Thanks again.
Yeah, I would like to second Vijay, because I'm one of the portfolio managers that have been working very, very closely with the HPC group, Forrest and the OCO office, Eric. And one of the things that happened the last 2 years is people support, basically. They could, there are messages that can be, like if a system fails or something like that, example, Andy or Dim can directly communicate, say, hey, JET failed this evening, what happened? And the response time, sometimes I found late, even in the evenings, a response time was less than 3-4, within a few minutes. And that's amazing. And things are 5 years, I've been with the system for the last 12 years, but the kind of things that are happening at high speed, and thanks to Forrest and the whole, Forrest, Eric, name them, everybody has been helping to put this HFIP. HAFS wouldn't have been this successful without the HPC system and the help. Having said that, Frank is here, the next one.
I think my questions are mainly for Catherine and the EPIC folks. How are we going to support the infrastructure development moving forward? DTC, I heard, Catherine, you're stepping away from that. And then EPIC is trying to pick up some of that. Where are we in that transition? How is it going? Are we making progress? I mean, we heard from Sanjao that they had a workshop. In the past, DTC would coordinate that. I don't know if EPIC was at the workshop, or they participated, or they were part of it, had any say in how we ran it. You know, it was kind of done from scratch by AOML and the NSUP folks. Are we going away from having the training? Because if we're going to have any supplementals or we're going to have any advancements, we need to maintain the capacity. These guys are giving us phenomenal HPC resources, but how are we going to use them? How are we going to build capacity? How are we going to train the next generation? If we're going to get funding and we need to support outside collaborators, we need to get them trained. And if we start training them after the money arrives, we're not going anywhere. So I don't see the coordination yet. Where is it? How are we doing it? Recommendations.
Yeah, great point, Frank. This is Gus at HRD. Just to follow up on that, I mean, one can wish, but the way things were working with HWRF and those interactions where, we had support sort of sitting in the middle of the science and the R&D machines. I mean, that was one of the key reasons why HWRF was able to progress into what, one of the best models in the world. And, I feel like without that support, a lot of that's falling onto, the science, the scientists who are doing the work. And, I want to look for any option going forward to avoid, my staff spending 25% or more of their time on these key issues in terms of figuring out how we're supposed to be running these models on these different systems. And with all the new systems coming online, it's very exciting, but I'll admit I'm a little bit scared because it's a lot of work ahead of us in order to get these applications running on those machines and for, the experiments to actually move forward. So I don't have, maybe there's a question mixed in there, but maybe just more of a fear and concern. So.
And also included in this discussion. Yeah, HPC, any response from you or Cameron?
Well, before anybody responds, I think I also want to pile on. As portfolio managers, Gopal, myself have a huge responsibility to make sure the resources are used efficiently. And if you look at the usage, it's not looking good. We are not doing justice to all the requirements that we have and the resources provided to us. And partly, I agree with Gus, the reason is that there is no sufficient support for running these models on these different machines. And I don't blame the developers for not making any adventures because that takes away a lot of time from them. Porting models to different architectures is not as easy as it was in the past. We have architectures that are changing almost on a weekly basis sometimes, particularly the data assimilation, for instance. The JEDI is a monster. Likewise, UFS itself is a huge enterprise with a lot of dependencies. And it is unfair to ask for developers to fix those infrastructure issues or machine-related issues. So I think collectively, this group has a responsibility to make sure we have sufficient resources to use those machines efficiently and do justice. We are asking for more resources. Kevin has shown how many people have requested resources, and if I ask how much of the utilization is happening, say for instance on C6, practically not much. And JET has not been useful for running experiments as well. So I think there is an onus on us as well as on those who are involved in providing support like DTC or EPIC to collectively address this problem.
The big issue I see, Vijay, we have this new DA consortium. Are they going to use these resources? Do they know how to utilize the resources? I mean, we're putting all these things up that we're going to do, but do we have the trained talent? I mean, we raised the issue about DA. Now we have a DA consortium. How are we going to utilize that DA consortium to advance our needs? Yeah, I mean, I'm sure they're going to try and advance all those needs, but on the HAFS side, I think, the HFIP has always provided some kind of infrastructure support besides HPC, besides code. I mean, the key to the development that Vijay alluded to was getting code in people's hands that they knew how to run it, then giving them the capacity to run it on the HPC. But right now we have a huge capacity HPC. Are we still doing the job to get the people up to speed to utilize it? That's the question. And if not, what's our strategy? We need to develop one quick.
Let's go to East and then go to Cameron.
Yeah, and running the code in one machine is fine, but when we switch to different operation system, the library issues or spec stacks, that kind of stuff, I'm not quite sure who we ask for or we seek for help.
What libraries are people using?
Yeah, the major, I mean, before I go to Cameron, this was one thing that I wanted to raise myself as a developer. When I go run a system, I was running a couple of systems, HAFS, IOLA, as well as HWARF. The next time I go to run the system, I'm not able to run it basically because something has changed. And we are all working towards it, but we invest a lot of time on this. One of the biggest issues that I'm having is the changes in the stack, basically. Stack, and we have moved from an architecture which was different. For example, HWARF is still easy to run. But when we move to HAFS, it's all based on stacks. Even to get NCView up, you need to have modules. So my question to anybody, how do we go about this in solving this issue, basically? And this is, I mean, because EPIC is involved in this, that's why. Cameron, go ahead.
Yeah, thank you. And I just wanted to follow up. So on the questions about like porting to new machines with HAVs and library maintenance and how EPIC is involved with the SPAC stack there. So we are, like I said, maintaining all of the stacks on the NOAA platforms. So that involves like actually doing the SPAC development to get all the libraries upgraded and run the installations, and then do the testing for porting to the weather model and other UFS applications right now, SRW and LandDA. Those are primarily led by EPIC to ensure that the stacks work properly with the weather model and those other two applications. And we do provide limited support for other applications and discussions if questions come in about library issues going on with the stack there and workflows or certain components of the repositories, not functioning with the stacks. Sometimes it comes down to, is it a library issue? Is it inherent to the stack itself? Or is it something that needs to be adapted in the application workflow or an inconsistency in the repository itself? That's not necessarily a stack library issue. We try to identify those things and address what we can accordingly. At this point, and I can't speak directly. I would defer to Maui, the EPIC lead or other EPIC management regarding expanding EPIC's involvement in porting HAVs to new machines and providing additional support, because I have heard that there's just not enough time for developers to be worrying about debugging, issues related to the stack or, different workflow issues that are arising on various machines. I would say that we respond as much as we can to inquiries in the user support email and forum or GitHub issues and discussions, but any large scale feature requests like this would be best sent to that support email, and then we can take that to EPIC management. So if there is more desire on the HAV side to have more support to port to new machines, the more requests, the more inquiries we get about that, we can take that to higher level and have those discussions. But at this point, from my understanding, what's within scope is what we're currently providing in terms of the limited user support and the documentation and just facilitating the call. I have personally tried to work with and Ratko Vasic as well, who kind of leads the SPAC stack effort on my team at EPIC, work with HAVS developers who are having issues with SPAC stack as much as we can, as Jet is transitioning to a different storage system, as we've upgraded several machines to the Rocky 8, Rocky 9 environments, and built new stacks. We try to offer as much support as we can. But in terms of concrete, dedicated support, I think that if inquiries are sent to Epic, those discussions can be had at a higher level. I hope that helps answer some of the questions here.
Before Kevin? Okay, yeah, so from the DTC perspective, I did want to respond to Frank's comment about things like the training and the user support that we were providing. The way that, we had a transition plan in place, and unfortunately, the way the timing worked with when we started engaging and when Epic had their descoping was unfortunate. We did try to provide as many resources as we could as far as the training and things that we've done. And I will say that the Epic team was very engaged with us as far as trying to get, some documentation resources going. So at least there's some of this like quick start guides going, but it's just been a little bit of a difficulty. And so I do acknowledge that there is, we didn't want to hand it off and have it, fall on EMC and HRD and other folks, but we're trying to navigate it the best we can, and we understand that there is a bit of a gap here.
Thank you. So this is Maria from EMC. So this is related to what Cameron was saying. So from time to time, so HAFS is publicly available. So in theory, external users could get the HAFS code and try to use it in a different supercomputer. So from time to time, we get emails from external users trying to run HAFS. Like in this machine, I think is derecho. And so we are truly super happy to help these users. But first of all, we don't have access to those machines. And second, that takes time out of our time, to do development. So whose responsibility is it to support these users?
I'm not going to answer that question.
This is Daniel from EMC. I first also want to appreciate all the Epic support, DTC support has. I know the transition is difficult, but Epic has already picked up some of those HAFS side support, like coordination, the HAFS development committee meetings, some of their HAFS repository maintenance. But again, I think we do have some challenges over there, especially as actually Kevin mentioned, HAFS is one of those earlier applications we were able to run on C6, C6. Those are basically because of we have those team members who basically volunteered or in-kind contribution to work with Epic for the spec stack or other issues with the system admins. We were able to migrate and porting HAFS to C6. However, this, again, it's not long-lasting, sustainable. We actually do not have enough resources to support all these kind of porting maintenance. It would be nice we have like someone from the community. Also, Maria bring a good point. We still have requests at HAFS GitHub repository requesting direct support. But we do not even have access. So another point I want to bring up is, if I recall correctly, Epic supports HAFS is not even tier 1 priority, given HAFS is one of those earlier actually operation system, the UFS-based operation system. Is it possible to lift the priority for HAFS or Hurricane application support a little bit? This is more likely for the management consideration.
So I guess I can try. This is Kevin from STI. I can try and address. I mean, we've tried in the past to put, the HAFS transition to a Hurricane application, build that into the Epic task order scope, and get that support for building on whatever tiered platform. But in general, just provide support to the external or broader UFS community to do the HAFS development. So I think that is something that we need to address. And again, it's that separation of concerns. We want the NOAA teams focused on development, and the more we can rely on Epic or even the community, the broader community for support. Build the, infrastructure like the forums and those sorts of things so that everybody can engage if there's a problem. Maybe it doesn't have to just fall on one party, but one party can kind of facilitate and enable. So I'll just add that piece. I was going to sort of take a step back to the general question that we were talking about maybe 5 minutes ago, but maybe I'll put that on hold. So if anybody else wants to speak to.
Yeah, I would like to do a step back a little bit. When we're talking about supporting software, there are 2 or 3 different things that we need to do. So what Epic and what the UFS and what NSGPS before that started with was the recognition that it was a multi-million-dollar effort just to move a piece of software to a machine. So the number one thing, most of the codes that we've been working on is to make these codes more portable. And the fact that we complain about the fact that we are righteously complain about the fact that it's hard to move. We're actually moving and actually running on all these machines, which is a step forward like nothing else. The other part of doing support is to figure out who is actually doing the support. And the best way of, a good way of doing support is to have a trained community. And so with the global weather model, with the regional weather model, we started with porting the code. When we had the discussions about whether or not we would have a HAFS operational model release or not, we don't have money to do everything. And we decided that it was more important in this specific case to transfer the HWORF community to HAFS than to do the support of the code itself. And so it basically shows that we're making reasonably good progress with what we want to do with building a community and community modeling, but with none of the applications we've had sufficient resources to do software engineering, software support, and community building. And usually we have picked only 1 or 2 of them. And we have to realize that the choice was made in discussions between Epic and weather service and the UFS steering committee members, that it made more sense to do the conversion of the community first with HAFS. And so this is a reason why we have potentially issues a little bit more with the software. And so what we really need is to recognize that that Epic is basically just having seed funding for a real community support, and that they tend to, and I'm not working for Epic, so I'm sitting on the outside looking in a little bit, but that Epic is actually doing pretty effective and good work with what they can do, but we have to make choices about what we put our money on. And I don't think everybody realized that. So these 3 things that we decided to do slightly different with HAFS, because we already had a community in HWORF.
Yeah, I'm not criticizing what you did. I'm saying what are we doing going forward?
Yeah, but the choice between supporting the software or converting the community was a very deliberate choice, and I think it actually worked. If you look at AMS last year, with the WRF and the HWRF and the HAFS community, we actually see, if you go to AMS, that there is already a lot of work done by academia and other people with the code, which is not quite caught up yet with the other codes.
Well, this is Vijay. I wanted to bring up one more issue in terms of building and sustaining communities. The one that demands probably some additional attention. When CADR was mentioned, for instance, how CADR can support, say, data assimilation development for NOAA or the vice versa. I think having community from outside of NOAA accessing our computers is still a challenge. We cannot put them on any of our RDHPC. Of course, MSU systems are a different story, but they don't provide all the data support or other restrictions in utilizing those machines. So I think corporately, we used to have people coming on to JET or HERA from outside, but we stopped doing it for various reasons. And the other important point is supporting data support, providing initial conditions, boundary conditions, or any other data sets that are required for people to make experiments. I don't think we have done a good job in figuring out how to do that efficiently. We are making exceptional effort from the same team that's volunteering to do the porting across different machines, also do the community support. And, this problem has been recognized for a while, but not enough in terms of providing any solutions. So I think we need to corporately think of how to do this community support, community engagement more efficiently.
I think we'll go to Cameron first because probably this is all related to what you guys are talking about. Cameron, go ahead.
Yeah, thank you. I just wanted to go back again to Maria's comment about, and it's related to the overall the discussion here. Maria's comment about derecho and Ben spoke about it as well. And I do just want to say that we maintain the SPAC stack on derecho, and like I said, do testing to port the weather model and SRW right now to derecho or to the new stacks, and derecho is included there. In terms of porting HAFS to derecho or supporting HAFS directly to function fully on derecho, I would recommend just continued inquiries or submissions of requests for the support to the EPIC email. And like I said, we'll do our best to look into it, and we know it, but it ultimately comes down to us needing to raise it to upper management and to have those discussions. And as Catherine mentioned, kind of during the DTC transition phase out of overseeing the support and regression testing, et cetera, for the HAFS repository, there was a descoping on the EPIC side, came down from Dorothy Koch's suggestion of a reprioritization and focus on specific applications, and then like Hendrik mentioned, user or community support and development. And so pragmatically right now it comes down to a capacity, from my perspective at least, just an overall capacity from my team, and then EPIC as a program in general. So considerations of porting to new machines and offering more HAFS support, with using derecho as an example. I think that if further requests come in and discussions are had at a higher level with EPIC management, I think that's where that would need to start. But from my side, we do support and maintain the stack on derecho, and I believe have tried to offer some limited user support for the stack questions I've received via email on how to run HAFS on derecho. But we just currently don't have the capacity to fully support that port.
Thank you, Cameron.
Yeah, thank you. Just going back to what Vijay said a little earlier too, on the fact that it still is very hard to get people on NOAA machines. And that is basically, it always was a problem, but after 9/11, it became a real mess. And so that was one of the arguments for going to a community modeling approach. And so, no, I don't take this as critique, but I think we're on the right path if you just see how many more people are working with all these codes already. And we just need to recognize that we really do need to properly support this. And up to a level, I'm not sure if my experience with the smaller community will properly translate to bigger communities. But on the wave modeling community, we've had several hundreds of people that are all trained on doing the code on any machine you can think of. We've ported it to any machine you can think of. And with that, a lot of the support in that community, because the community is so mature, it is literally somebody puts in an email in a mail server, And normally, because we're only 1/5 of the day online, technically, the questions are already answered and taken care of by somebody else in the world. And so we hope to get there, but we do need to make the investment in the engineering, in the support, in the training to get there. And so that may be the other thing to try and bring up to the people who actually hold the purse strings above the level of the folks in the room here, that we really can only consider EPIC to have funding at the seed level, not at a full support level, and that we need funding, not indefinitely, but that we need funding to get over that hump to be in a mature software world. And that at that point, you are going to be in a situation where you can support it with less money, and where you can put more money in research rather than in building the community and supporting the code.
Okay, Hendrik, I think that's a good natural stopping point for this session so that we can transition over to our lunch break. I do want to say that we will have more time to talk about HPC and technology, as well as forecasting SPES and IDSS, and then a wrap up in the second session of the afternoon. Those are structured 30-minute designed for this type of discussion. And then the session that's immediately after lunch is on R2O and OTR. Will be chaired by Gopal and Pablo.